Well, hello. Hi, everybody. It's been a minute since we've hosted an OTel in practice, so we're very excited to be back this month. As a refresher, and for those of you who are new here, welcome and welcome back. OTel in Practice is a live stream program hosted by the End-User SIG, where contributors and end users can come on to the show and show us something cool that they've done with OpenTelemetry. So if that is you, we do always welcome people to register their interest. So definitely reach out to us. We'll share how you can do that after the show. But hello, I'm Reese. I am one of the OTel community managers, along with Adriana Villela, who is behind the scenes today. So she's going to be taking care of all the back-end stuff. And I'm coming to you live from Portland, Oregon, as usual. Sometimes I may be somewhere else, but I'm thankful to be home right now. And yeah, as always, we would love to hear and see where you're tuning in from. So if you want to drop into the chat, whether you're watching from LinkedIn or YouTube, and just let us know where you're coming in from. It's always fun to see. We've had people, all over like Europe and Asia. And so, it's just a nice, fun reminder that despite being on different continents, we're still connected. So today, we're going to be exploring a CNCF project that I just found out about recently, and I think is pretty cool. It's called OpenChoreo, and we're going to be chatting with two of its core maintainers, Akila and Nilushan. So OpenChoreo is a CNCF sandbox project that functions as an open source IDE or internal developer platform for Kubernetes. And they're going to be talking to you guys about how they use OpenTelemetry under the hood. Without further ado, we shall bring on Nilushan and Akila. Hello.
Hi, Reese. Hi, everyone.
Hi.
Nice to be here on this show.
Oh, yeah, we're happy to have you. And I believe you are both coming in. Are both of you coming in from Sri Lanka?
Yes, that's right.
That's pretty cool. I've seen beautiful pictures. One of my best friends is from Sri Lanka too. She lives in Hawaii now, but yeah. Yeah, so I will let Nilushan and Akila take it away. And then as questions come up, feel free to put them in the chat and we will get to those afterward. And yeah, excited.
Thank you, Reese.
Oh, thank you.
Hi, everyone. Akila and I are glad to be here on this OTel in practice session. In today's session, we'll be talking about how OpenChoreo and open source IDP is using OpenTelemetry in the backend. My name is Nilushan, and I'm working as a maintainer of the OpenChoreo project within WSO2.
And I'm Akila, so I'm also a OpenChoreo maintainer from WSO2.
So during this session, this is the plan we are going to follow. First, we'll explain to you all what OpenChoreo is and what the problem it's trying to solve. And after that, we'll show you how we use OpenTelemetry inside OpenChoreo. So I'll start off this session with a quote by Satya Nadella. That is, every company is a software company. While this seems simple, if we really think about it, we have software running all around us. Even if we look at some company that is an airline, a company that is booking hotels, or it could be a restaurant chain, there is software all around us. When we try to book an airline ticket, we interact with a software. When we try to book a hotel room, we interact with another software. When we try to order something, when we want to order takeout or make a reservation at a restaurant, we will probably be interacting with some sort of a software. Now, all this software starts as a piece of code written by a developer. But to get that software out into the public for people to use, it needs to go through several steps. That includes things like building it, running unit tests, then deploying it, and deploying won't happen into production straight away. It needs to be deployed into lower environments first. It needs to be tested, needs to be exposed through an API gateway, and so on. Also, after you run them, you need to see what's going on in your application. So you need observability. Now, when organizations want to go through this flow, they use internal developer platforms. And developers who are using it, they expect to have a golden path in it. They don't want to be integrating different tools and technologies to get their work done. They want to focus on the business logic and write their software, and they want them to be out in the open. Now, to do that, you need an internal developer platform. Now, these platforms could be built by scratch, and that is possible. But the thing is, doing it from scratch is a little bit complicated. See, the thing is, there are so many tools out there if you need to build a platform like this. Take observability for an example and look at the CNCF landscape. There are so many observability tools for logs, metrics, tracing, event collection, and then if you look at API gateways, there's a whole lot more. So if someone wants to build it from scratch, there's a lot of overhead to figure out which tools to use, how to wire them up, and so on. And observability is also required, and that also takes time to set up. So if organizations want to use an open source internal developer platform straight away, they could use something like OpenChoreo. And that's where we both come from. OpenChoreo is an internal developer platform, like Reese mentioned, and it's a complete platform. What we mean by that is it's ready to be used from day one. Once you get OpenChoreo up and running, you have everything that you need. Your deployment pipelines, your observability, your API gateways are all there. And then it's a modular product. You can enable or disable what you want. If we take observability, someone could enable only the logs or metrics. And if they want, they could enable tracing. Everything is modular in this platform. And finally, it's open source. It's an Apache 2 licensed product, and it's currently a CNCF sandbox project. And in OpenChoreo, observability plays a key role. Observability is not something you add later on. It comes with the platform itself. Now, OpenChoreo has multiple planes. There is a workflow plane, there are data planes, and a control plane. So, Akila, would you like to introduce these planes to our audience?
Of course, Nilushan. So OpenChoreo has built like keeping in mind the modular concept, and we have like separated the concerns into different planes. So if you consider, we OpenChoreo provides 4 planes, namely control plane, data plane, and optional workflow plane, and as well as observability plane. So what the control plane does is it's basically the controller for OpenChoreo concepts you get, like the developers get the golden paths, like creating projects and components inside them and promote them to different environments. So this intent is expressed to the control plane, and control plane has the controllers to convert them into the runtime workloads, and then the runtime workloads go to the data plane. So it's basically the runtime layer. You can figure out different topologies. You can if you want, you can run all these planes in a single Kubernetes cluster, or you can separate out to multiple clusters as well. So data plane becomes the runtime layer for the user workloads that the developers write the software's developers ship. And if you are an organization building the software from source code and then deploy, so we have provided an optional workflow plane. You can enable it and use it. Also, of course, when you're running the workloads in production, so you need the constant observability. So we have considered it as a core pillar and separated that concern into a specific plane for observability plane. There we provide observability features like logs, metrics, traces, distributed traces, and Kubernetes events. So using several tools available at the CNCF landscape. So we are shipping some default tools, but it's extensible by design. You can use any open observability tools from your vendors you like. So this is how we have designed observability in OpenChoreo. So we have the features like logs, metrics, and distributed traces. So OpenTelemetry provides a key role in our distributed traces setup. So Observability plane runs all these observability tools, and it's based on the hexagonal architecture, also called this port and adapter pattern, which will be Nilushan will be talking on. Yeah, Nilushan.
Yeah. So just to give a quick highlight about this observability architecture that we have observer as a key system components, and we have separate APIs for each area of observability. We have APIs for logs, we have APIs for metrics, and then traces. Also, observer has these ports. That's what we call them in the hexagonal architecture. And then users can plug in various adapters. Now, these ports are defined through an API contract. So we have a tracing adapter API spec that we have published in OpenChoreo. And then we have tracing adapter modules that adhere to this spec. So there is a tracing adapter based on OpenSearch, one based on OpenObserve. Then we have ones that use cloud provider backends like AWS, Azure. All these come as tracing adapters. Now we have OpenTelemetry playing a key role in these adapters. So let's get into how we use OpenTelemetry in OpenChoreo. In OpenChoreo, we use OpenTelemetry for two main features. One would be for the distributed tracing feature, and other one is Kubernetes event collection. Now, the reason that we use OpenTelemetry for our project is OpenTelemetry is a very popular open source project. And one of the key reasons is it's vendor neutral. The standard is vendor neutral by default. If we use the provider specific standard in OpenChoreo, that means it would be tied to a particular backend provided by a certain provider. But by going with something like OpenTelemetry, we are able to use an open standard so that it could plug into several backends. Now, even in the tracing adapters that we have, all these adapters use OpenTelemetry to collect the traces from OpenChoreo components. And then OpenTelemetry has a pipeline with receivers, processors, and exporters for so many use cases. So recently, one of our colleagues came to us and we were having a chat about a way to count the number of traces. He was working on a task for that. And then we were able to find a processor for that, an extension within OpenTelemetry. And then there are OpenTelemetry SDKs for almost all the popular languages. Now, OpenChoreo is an internal developer platform, and users can write their applications in any programming language that they want. So if they want to publish traces, they could use the OpenTelemetry SDK and enable tracing. And since OpenTelemetry is supported by all these languages, enabling tracing is very easy for our users. And also, the OpenTelemetry core is extensible, and the Kubernetes event feature that we worked on required us to extend this core a little bit. Let me explain about the distributed tracing that we have in OpenChoreo. Now, distributed tracing is required when you want to debug microservices. In a application that you have, let's say the GCP microservice demo that is used in so many examples, you have several microservices running. And if you need to trace the request going through each of these services, you need to have distributed tracing. An internal developer platform is not very useful if users can't see what has happened in the system, because when you serve software to your users, when things are going well, everyone is happy about it. But when things break down, you need to figure out what happened. You need to understand where it went wrong and how you could prevent it. And distributed tracing is a feature that you could use for that. In OpenChoreo, the OpenChoreo components generate the traces, and we have an OpenTelemetry collector to collect them. This OpenTelemetry collector has a pipeline, and it defines OpenTelemetry receiver, and then it has several processors. There is a tail sampling processor by default, and there is a Kubernetes attribute processor as well. Those are used to collect context about which component or which pod generated those traces, so we could show them to our users. And then at the end, it sends the traces out to different backends. So based on the tracing modules that platform engineers enable in their OpenChoreo deployment, they could send the traces out to OpenSearch, OpenObserve, AWS, GCP, or to Azure. These are the exporters that we use for that. Now, in OpenChoreo, there is a backstage portal that we use to provide the UI to the users, and we are able to show these traces inside this UI. And here we are able to show the traces from all the components running within a project. Now, the advantage of running everything within the OpenChoreo system is that although the traces are generated by different pods, different containers, they could be mapped back to OpenChoreo concepts such as projects and components. And for that, the OpenTelemetry Collector pipeline that I mentioned earlier has been very useful. Next, we have the Kubernetes events feature, and Akila will be explaining that.
Yeah, thanks, Nilushan. So we have this Kubernetes event. So if you are working on the Kubernetes space, you might have been using kubectl get events command a lot, right? So that works most of the time. But what happens is when you are doing a postmortem for an incident, like after basically rectifying the situation for trying like debugging for several hours, and finally you get it back to normal, but then you want to do the postmortem.
Akila, sorry to disturb, can you share the slides? Okay.
I think I have shared the slides.
Okay, now it's visible.
Yeah. So like I was saying, so when you finally get an incident resolved and everything's back to normal, then you need to do the postmortem and prepare this root cause analysis, right? For platform engineers do that. So you need the data about what happened 3 hours ago or 5 hours ago. So currently, most of the systems provide very easy collection pipelines to logs, matrices, and traces. So we needed to provide the Kubernetes events persistence feature into OpenChoreo so that you won't be lost when preparing the postmortems for your incidents. This is where we basically use the flexible and extensible core of OpenTelemetry, where we use the K8s events receiver from the OpenTelemetry Collector contrib to watch the Kubernetes events running in the Kubernetes events of the user workloads in the data plane cluster. And what we needed in custom was, like Nilushan mentioned earlier with the distributed traces, we needed to way to map the Kubernetes events into its origin and as well as the origin OpenChoreo concepts. So we have concepts in OpenChoreo like project. The project defines a certain domain, and we have components. Components defined each microservice you deploy into that domain or the project. So we needed a way to map these events back to the OpenChoreo project. Which project generated this event? Which component generated this event? So that's where the OpenTelemetry extensibility was very useful to us. So we developed a custom processor to enrich these Kubernetes events using the involved object of that event, which Kubernetes resource fired that event, and we enrich the Kubernetes event object with the labels and annotations and stuff of that origin resource. And as Nilushan said earlier, then we were able to publish these enriched events into several exporters. So we can use OpenSearch, OpenObserve, or any other logs exporter you have. So this provides this platform aware context to the events. So this is how our custom developed architecture worked under the hood. So we use the K-test events receiver from OTel contrib, and we developed this K-test event enrich processor in-house. So we are actively developing it. So what this is actually, we have a it stores labels and annotations of the custom resources in the Kubernetes cluster, and when an event comes through the uh, event receiver, we looks up for the origin of that event, and then we filled up the information of labels and annotations from our store, and then we publish it into the exporter. Here, as an example, we have used OpenSearch. So we are actively still working on this K-test event processor. It's currently only vertically scalable because we need to add some leader election algorithms and keep the stateful status ongoing to make it horizontally scalable, and then we even plan to contribute back it to the OpenChoreo OpenTelemetry Collector contrib repo. So that's how the Kubernetes events architecture works under the hood. And we have just like the traces view, we have provided the native experience to visualize the events with related to the components that it was generated. So in this case, if you see, we have shown events fired from several Kubernetes resources here: pods, replica sets. So all those Kubernetes resources belongs to the front end component in this screenshot. So that's that level of feature rich experience we were able to give via OpenChoreo with the use of extensibility of the OpenTelemetry. So I think we have a demo. Nilushan, you can start on the tracing demo.
Yeah. So for this demo, I have deployed OpenChoreo on my local machine. It's running inside K3D. And this is the OpenChoreo Backstage portal. And inside this OpenChoreo deployment, I have deployed the GCP microservice demo. Now, inside this catalog, we have a list of projects. So a project is a collection of related components. And if we go into this GCP microservice demo project, we could see all the components running inside. I have the front-end component running here as well. And this is the online boutique that is deployed through this GCP microservice demo. So for this demo, I'll be showing how we could perform some actions on this application and see them through the tracers view that we have used OpenTelemetry. Let me quickly add a component. Let me select an item from this store and add it to my cart. And after that, I will show how it appears in the tracing view. Now, in the Backstage portal, we have the tracers view at the project level, and we show each trace over here along with the number of spans, and users can expand each trace and look at the span in detail. So let's see what happens when we add this sunglass to the cart. From the application side, it got added. Now I have $28 in my cart. Let's give it a few seconds and see whether this event appears in the trace list. Okay, so we have a trace from the front end. If I click on it, I could see several spans. There we go. We have the add item span over here. And if we click on it, we can see all the span details. Now, Akila and I both mentioned about using various parts of the OTel collector pipeline to get things working. Now, this is how we have done that. So if you look at this span, its resource attributes show these OpenChoreo concepts. It shows the OpenChoreo component, the component UID, the environments, namespace name, projects, and everything. These are all collected by the Kubernetes attributes processor in the OpenTelemetry collector. So when this OpenChoreo component sends out these traces, the processor intercepts them and it's able to record these values from the pods labels. And that is done automatically using the OTel collector pipeline. And it's because that we have them here, we are able to map them back to these OpenChoreo concepts of projects and components. Now that was for this add item action. Let's see what happens when we empty that cart again. We should see a similar trace appearing over here. Okay, so we have another trace from the front end, and it has this empty cart action invoked. So if we look at these attributes, we can see that the empty cart method was invoked, and we can see all the span attributes and everything over here. Now, the other advantage of collecting traces like this is to see if there are any errors in the application. So to see that, I will simulate a breakdown in the GCP microservice demo. So for this, I will delete one of the components that we have. Just give me a second, I'll share my terminal as well. Oops, sorry. Okay, now I hope you can see the terminal. I'll select another product again, and before I add this to the cart, I'll delete the pod that is running the cart service in order to simulate this failure. So we have this cart running over here. I'll delete the pod, and while it's deleting, I'll try to add this to the cart. Okay, so we got an error over here. Now, this is what's user facing, so the user sees the error, but if platform engineers or developers need to identify what went wrong, they need to look at the traces. So let's go back to the trace view and see if there are any errors. Okay, so we have a trace containing an error, and this shows that the error span is coming from this add item action. And we could see a connection failure over here, and the OpenTelemetry status code is an error. So from here, we could identify that something has gone wrong in the application. And because we have tracing enabled, we are able to see where it went wrong. And that's the advantage of having tracing enabled in these applications. And the other thing that I wanted to show you all was that I deleted a pod using kubectl commands. Now with OpenChoreo, OpenChoreo is like a layer that is added on top of it. It complements Kubernetes. OpenChoreo does not hide the Kubernetes layer that is running underneath. It adds some other things that helps developers use Kubernetes for their platform. And that's another advantage of OpenChoreo. So for the next part of the demo, we'll be showing how we use Kubernetes event collection. And Akila, over to you to show that part.
Yeah, thank you, Nilushan. As the GCP microservice demo Nilushan showed earlier, so I also have deployed this microservice demo application on my locally running OpenChoreo setup. So as you can see, it's like quite a big project with like 10 plus microservices. So what I'll do is, so I'll show you some scenario. So we have this cart component from the microservice demo project, and it's currently deployed to dev environment only. So I will like promote it into staging environment to see what we can gather from the Kubernetes events there. So you can see it's in the pending state. So all of this now the OpenChoreo control plane is taking over and like deploying it to the data plane. Once the application is deployed to the staging environment in the data plane, you will see we get this pending to active state. So you can some few features in OpenChoreo side, you can see what's happening under the hood in the meantime as well. So still the pod is being created. In the meantime, we'll see what kind of events generated with related this cart component. So if you go to events and select the staging environment, which I just promoted the component to, you can see we got bunch of Kubernetes events generated from different Kubernetes resources, right? Pods, deployment, and replica sets, and it all tells a story before the application got up and running actually. So you see the deployment scaled up the replica set, and the replica set created this pod, and you also can see, like Nilushan mentioned, which component and project and namespace this belongs to, as well as the image was pulled and container was created and stuff. So if you have got any image pull errors, so you mentioned a wrong image tag, or you don't have a image pull secret mentioned there, so you can see if that's the case, you can see you can troubleshoot it here. This comes before logs, metrics, or traces, right? This is like in the Kubernetes level. So you get the you actually get a missing layer of observability using this events feature in OpenChoreo. So that's how you see like visualize events and what gets underneath. So I'll show another scenario like how you got something to troubleshoot. So for that, we'll like consider a scenario where it's Black Friday and everyone is like ordering through your online store like crazy, and then your deployments was needed to like scale up, right, to serve that massive amount of traffic. So we currently don't have like that kind of traffic generated. So to simulate that, I will like increase the replica count to simulate this scaling scenario. So I will add like 20 replicas of this card component is going to be running now in my development environment. Like let's consider it as a load test. And if you do that, so now the 20 replicas of this card component is getting created, but my local Kubernetes cluster cannot actually handle this level of traffic, this level of resource requirements. So maybe after Black Friday, this level of traffic doesn't exist, right? So it only existed for a certain amount of period, but the application could not get scaled well. So what the users of your application experience is, you get like you're ordering to add to cart functions are not getting successful. They experience degraded performance of your application. You don't want to have that. But once it's morning, once it's the next day morning, you don't have that level of traffic in the system, and you can't even see what has happened there. So that's where this event feature is like very useful. So if you go to like the development environment events again, you can see a bunch of events there. So all seems to be normal, but if you look further down, you can see like morning events as well. With the failed schedule reasoning, seems like my VM where this Kubernetes cluster is running does not have enough resources to scale to like that 20 level of 20 replicas of my component. So once this component replica count is scaled down back to 1 or 2, you won't see these events, because usually by default in Kubernetes clusters, these events are ephemeral and will be gone after about 1 hour. That's the default. So that's where we have been seeing this feature is very useful, and we have built all this using the OpenTelemetry pipeline. So that's what I wanted to demo about this Kubernetes events thing. If you have any questions on that, feel free to ask away. Yeah, back to Nilushan.
Thanks, Akila. That was a lovely demo on Kubernetes events. And while talking about this, I think we had to be thankful for the OpenTelemetry community. It's because of this OpenTelemetry collector, these pipelines, all these processors and everything, we were able to use them in the OpenChoreo project as well. That's it for today's session and the demo. If you all have any questions, you all can ask them now.
Yeah, if you want further information about OpenChoreo, you can visit this website through the QR code. If you have questions waiting to be comes to your mind afterwards, you can join our Slack and ask it away when it pops to your mind. Also, if you wanted to look at the source code, contribute, or open any issues, there's our GitHub. If you find this project useful, yes, please have a look at that. I think we had some questions in the chat as well, right?
You did. First of all, Nilushan and Akila, thank you so much. That was like very informative and clear. And it's really cool because like I was seeing the questions come in, and then I think some of your OpenChoreo teammates were helping answer those questions. So that was pretty cool. But yeah, we do have one that just came in. So yeah, how can OpenChoreo use OTel for its logs and metrics modules?
Okay, so in OpenChoreo, we have this extensible architecture when it comes to observability modules. There are mainly 3 types of modules. That's the logs modules, the metrics modules, and the tracing module. Currently, we have used OpenTelemetry in the tracing module and the events one, but users could add it to the logs and metrics modules as well. So what needs to be done is they need to deploy OpenTelemetry and then configure the OpenTelemetry Collector pipeline to publish the events, to publish the logs and metrics to the backend that they are using. So for example, we already have modules for OpenObserve and OpenSearch. So if they deploy it and configure the logs to be published to that one from OpenTelemetry Collector, it will work and it will show up in the OpenChoreo backend, the Backstage portal, the CLI, and everywhere.
Thank you.
And it could be a point of contribution as well. Someone could extend one of these tracing modules to, someone could extend either a metrics or a logs module to add OpenTelemetry support. That's certainly possible, and we would welcome all these contributions as well.
Adriana. Oh, you're still on mute.
Thanks. Yeah, I popped in from the background because as I was watching, I had some questions. My first question is, I noticed that you, in the OpenChoreo interface, you are able to display OTel traces. Now, do you also have the ability to allow your users to export your telemetry to any other observability backend?
So what I was showing in the Backstage portal, it was powered by OpenSearch running in the backend. Users could switch the backend to something else as well. OpenObserve is supported. Then there is AWS X-Ray that's supported, GCP tracing, then Azure tracing. All these are supported. So
I see.
Users could just switch the tracing module and send it to a different backend.
And was that was embedded in the UI?
Yes. So what happens is the Backstage portal makes an API call to observer. Observer talks to a tracing adapter and fetches the data.
So it fetches it from that backend into the OpenChoreo
that's
UI.
right.
Oh, that's cool.
So we have this hexagonal architecture in the observability plane. So we have a particular API definition for tracing adapters. So there is an API to fetch span details. There's an API to fetch traces. If someone adds an adapter to a new backend, let's say there's a new tracing backend called ABC, they add a tracing adapter for that. And if it matches this spec, it will work with OpenChoreo's clients, the CLI, MCP server, Backstage portal, and everything.
Okay, so it's really up to the observability backend to create an adapter following your spec and then be able to see that. Okay, that's super, super cool.
So that's another area where the community can contribute. There are several backends right now, but we are open for more backends.
Nice. What are some of the backends that are available currently?
We currently have OpenSearch, OpenObserve, AWS X-Ray, and then Azure, GCP. Akila is showing them. So these are the tracing adapters that we have.
Cool.
Yeah, we have a bunch of adapter modules here, like tracing, powered by several. Like some people want to use the self-hosted backends storage. Some people want to use the cloud vendor provided stuff. So we kind of support them all.
Awesome. That is
and then when
cool.
users install these tracing modules, what happens is it deploys an OpenTelemetry Collector and configures the pipeline to publish to this particular backend.
Got it. And my other follow-up question, your OTel collector, are you able to share your OTel collector config?
Yes. So we have them inside this repository called community modules.
Yeah. So this takes you to there. So this is example community module for tracing with OTel and OpenSearch as the backend. So we deploy here we deploy OpenTelemetry Collector, and we provide a pre-configured config map, but users can always extend it using our Helm chart. So if I show you the config we have at the moment, so we have this OTel-P receivers for applications to publish both gRPC and HTTP endpoints, and we have, since this is OpenSearch tracing module, we have an exporter to publish the collected traces to OpenSearch backend using the authentication when the users need. So we have batching as well here, as well as tail sampling, right? So here.
So and then we have that attribute processor as well.
Yeah, so the attribute processor is what makes it help to map the traces into our OpenChoreo concepts. So this labels from Kubernetes pod that the trace was published. So we enrich them using this Kubernetes attributes processor from OpenTelemetry Collector, and then do some tail sampling to rate limit. This is also configurable per user, and then this is our pipeline.
So, but to have that functionality, like to be able to emit the OTel data, you would need to have be configured to send the telemetry to a backend via an adapter, and you provide kind of the base collector config that OpenChoreo requires, and then they build on top of that, and then you extract the data via the adapter into the OpenChoreo UI.
So what happens is we have this data plane in OpenChoreo where user workloads run, and an OpenTelemetry Collector gets deployed over there. So what the application developers need to do is they need to configure their application to send traces to this OTel endpoint. And once that happens, this pipeline collects it and sends it to the backend. This observability tracing OpenSearch, it's a Helm chart. It's an umbrella Helm chart which deploys an adapter, which is currently a Go service. And then it also deploys the OTel collector. And maybe if it's a self-hosted deployment like OpenSearch or OpenObserve, it deploys that as well.
Interesting. Very cool.
Yeah, so the applications still need to be instrumented. So I'm sharing this GCP code of the GCP microservice demo. It's a well-known demo we just showed. So that app source code of that GCP microservice demo is actually some components are instrumented to publish tracing. So we have it just need the collector where to publish, right? So this is provided by OpenTelemetry Collector, which we ship from our observability tracing backends. So only this level of configuration is needed from the application, the component side. When the application source code is instrumented, you just need to give the tracing endpoint, which is the OpenTelemetry Collector. Then all these are wired up behind the scenes by OpenChoreo from us, and you get that lovely visualization.
Awesome. And I've posted the QR code for that, for the link that you're displaying on here on screen. It's currently blocking my face, so please scan. Amazing.
We do have a couple more questions in the chat if you want to get to those. I know we're coming up on time.
Yep. Okay, so here's the next one that came up. What was the most difficult problem you came across when developing telemetry stuff in OpenChoreo?
I guess we had to deal with a lot of tools for different telemetry signals. There were a lot of tools involved, various integration points, and sometimes like what we want directly is not possible. So we had to extend it like Akila had to do for events.
Yeah, for events, like we evaluated like several collectors. Like there's a bunch of collectors to watch the Kubernetes API server for events and get them published to somewhere else. But when we evaluate, we like actually couldn't get the hand on something like OpenTelemetry to do this custom enrichment as easy as possible. So it was still a bit tough thing to do because we did not had anything. We hadn't have done anything like that, like extending like collector pipeline. We have been using the processes already out there. So still we got it to work and still refining it, and hopefully we plan to contribute it back to OpenTelemetry Collector contrib as a new processor.
Right on.
And then I think we have
another question.
Can we filter events by text?
From the backstage portal, I think you're asking, right? Currently, like it's still in the development, so you can filter by environment where the events got published and the time range. So we can still we can easily add a text search filter that we hopefully should.
So do we have any other
so we
questions?
need to add it into the front end.
Yeah, and we'll include links to the repo and how to get in touch if you have any more questions in the show notes.
Yes.
Yeah, if you come up
and just really quickly, here's a link to the GitHub repo. Please scan.
QR code for the OpenChoreo GitHub.
Yeah, still, yeah, OpenChoreo is like we donated it to the CNCFs and we got it into sandbox in like early this year. So it's still in development and growing. We have in this 1.2 release, it was the latest one. So we are still growing. So we love to hear any feedback from you guys. So if you find the project is interesting, check it out and give it a star. Yeah.
Yeah. Will anyone from OpenChoreo be at KubeCon North America coming up in a few months?
Yes, there will be some maintainers. Yeah, they would be there at KubeCon in USA.
Yeah, there will be like few of our maintainers, and we will be in touch of OpenTelemetry as well. We hope to see you guys at the KubeCon too.
Yeah. I mean, yes, I will be there. And yeah, before we hop off for today, again, huge thank you to Nilushan and Akila for chatting with us about OpenChoreo. It was really awesome to learn directly from you all, and I think you both did a really good job like explaining things. And yeah, next week, Adriana and I will be back for this month's What's New in OTel. We'll be talking with McKaylee from the OTel packaging SIG. So lots of cool stuff there. And I will let anyone else, if they have anything else to add before we go.
And we would like to thank you all as well for having us on this show and for giving us the opportunity to share how we use OpenTelemetry. So thank you very much for that.
Oh, our pleasure.
Yeah,
This
it was
was
been a
so
wonderful
great.
session. Yeah, thank you guys. Yeah, hope happy to
Gen
be
Z
here.
heart.
Yeah.
And I will use this as a call to action for any other CNCF projects that are out there that are doing cool things with OTel.
Oh,
I wanna
yeah,
hear
yeah.
from you.
Yeah.
As you can
And
see,
we
this
just
is
have
the space for it.
And we just have confirmation from one of our maintainers, Samira. He'll be there at KubeCon USA.
Oh, nice.
Amazing. So check out the OpenChoreo booth in the project pavilion at KubeCon.
And check out
Salt
the
Lake
OpenTelemetry
City.
too.
Right on.
Oh,
Yeah.
yes. Not sure if we'll have a project pavilion booth, but we will have the OTel Observatory.
Yes, it's coming back, which is
More
very exciting.
more news to come in the
Yes. Yeah, TBD. Or I guess whatever. More details to
Yeah.
follow, right?
Yes.
Yes.
Awesome.
Amazing. And as we said, what's new in OTel is happening next week on Wednesday, the 26th
at 10 a.m. Pacific.
Yes, there you go. And 1 p.m. Eastern, 7 p.m. Central European time.
Yes.
Got all my time zones.
Central European summertime.
Oh, yes. Central European summertime. That's right. Amazing. Well, thank you for joining, and thanks for letting me pop in with some of my questions.
Oh, yeah. No, thank you. Thank you both so much. And we'll see you all next time.
See you guys.
All right. Bye.
Adriana, get the outro.
It's not working. Bye.